Hello world and welcome. I'm Rick, and today I'm going to be talking about keyboard mapping for the Vice family of Commodore 8-bit computer emulators. A while back, I fell into the rabbit hole of YouTube channels dedicated to old computers, particularly the early personal computers of the 80s. And particularly, my first computer, the Commodore 64. Channels like the 8-bit Guy and 8-bit Show and Tell sparked nostalgia. And not a little regret that I'd let my Commodore 128 go to the landfill long ago. Enter Vice, the emulator for the entire range of 8-bit Commodore computers. Launching it for the first time was like entering a time warp, throwing me back to my youth, and a fond memory of that time was typing in programs from books and magazines. And that was the moment Vice really started to annoy me. Vice is a brilliant piece of software, but like so many open source projects, it primarily serves the needs of its development community. And if the community doesn't share your interests in what their software can do, you aren't going to convince anyone to change for your sake. Most people remember the Commodore 64 as a games machine, and that is not at all an unfair categorization. But my nostalgia comes from it being the machine where I first learned how to write programs. And to use Vice to relive that time, I was going to need to type. And that means typing on, and this turned out to be important, my preferred computer, a MacBook. I need to be able to type on this as if I was typing on this. Using Vice, I found the mapping of my Map keyboard to that of a C64 was fairly good, but it had some quirks, and some keys didn't really work where they were placed, and some keys simply didn't exist at all. This is what the positional keyboard mapping looks like on a MacBook. Half the symbols over the number keys don't match up with what is on the keyboard. For example, Shift-2 gives you a double quote when the key shows an @ symbol, and the shifted symbols for 7, 9, and 0 are all off by 1. So, for example, Shift-9 gives a right parentheses when the key shows a left one. Then you have almost every symbol key on the right mapping to something completely different. In fact, the keys for minus and plus are reversed. Finally, since the MacBook, and in fact all modern keyboards, have only 2 keys between the 0 and backspace and the L and return, the third keys the Commodore 64 crams in there, the British pound symbol and the equals key, need to map somewhere else. To get the British pound sign, you need to type Option 3, and the equal sign is mapped to page down, which on a MacBook keyboard means pressing the FN, Option, and down arrow keys together. So the positional mapping is not going to work for touch typing in Vice. What about the symbolic mapping? This works much better, but the default mapping still has some issues. The Tab key has been mapped to the Commodore key. That's okay, I guess, but there should be better options. A number of keys are mapped where they work in a way that maybe makes sense on the Commodore 64, but not on a modern keyboard. For example, pressing Shift and F1 together, which on a Mac means pressing Shift, the FN key, and F1 together, will send F2, or Shift F1, to the emulator. But F1 is F1. Why do that? Especially when F2 is mapped to always send Shift F1 to the emulator. The same pattern is used for the right and down cursor keys. You can send cursor right with the right arrow, or cursor left with Shift right arrow. And again, if you press the left arrow, the emulator always gets Shift cursor right. Finally, because the Mac keyboard has symbols assigned to the shifted versions of some keys, the Commodore's shifted graphic characters are lost. For example, on the C64, Shift and plus create a heavy graphic cross, but on the Mac keyboard, plus is achieved by Shift and equals. There is no way to send Shift plus to the emulator. The fact is, the default symbolic mapping does let you type pretty normally in the emulator, but when the time comes to do something a little outside normal text, and those times come quite often when writing basic programs for the Commodore, it falls down. There has to be something better. I spent some time hunting for anyone who might have implemented a virtual on-screen keyboard that I could use as a supplement for when my Mac keys failed me. No luck on that. In fact, what I found was a thread in the Vice bug list that basically came down to, we, the developers, don't care about this and have no interest in doing it. Fair enough. I seriously contemplated if maybe this was something I could write up, but I've got enough to do keeping on top of work projects, and I had little to no interest in trying to remember how to get a C++ project going again. If they can be disdainful of someone wanting to use Vice for a purpose they don't care about, I can be disdainful of their choice of technology stack. Not that any of this got me closer to being able to efficiently type on my AirSat's Commodore 64. Enter the VKM. Vice does have key mapping files, and that seemed like a path to pursue. The vice key map, or VKM files, are dense and cryptic, and the in-file documentation didn't really make much sense to me on first read-through. But it was obvious there was some way to map a modern keyboard to these old Commodore keyboards. I was determined to make a useful mapping, and to make things harder on myself, I set myself the following requirements. Keep as much of my muscle memory for typing on a MacBook keyboard intact. Support all of the keyboards provided by the various vice-emulators, and make the keys mapped for these various keyboards consistent as much as possible. Here was my process. I started by finding pictures of all the Commodore 8-bit computer keyboards. There's quite a variety. In chronological order, there's the original PET with its calculator-style chiclet keyboard, the next generation PET with a somewhat more normal keyboard, the PET Business with its much more standard keyboard, the VIC-20 where things got even more normalized, so much so that the Commodore 64 has the exact same layout. Then there's the Commodore 16, which looks like the same layout but isn't, and the Plus4 with its funky cursor arrows, but a squared-up layout that made its way into the Commodore 128, which added a keypad and some additional keys. Finally, there is the CBM2, which technically predated the 128, but whose keyboard finally uses something very close to a standard modern layout. My goal for the mapping is all about typing, and duplicate keys don't produce different characters on the screen. Of course, this could be a problem if I encounter a program that is looking for certain keys by its key scan. Like, for example, more than a few programs I recall using the keypad as an 8-direction controller. But that is a limitation I can live with in exchange for being able to type in programs easily and with a minimum of rewiring touch typing honed over a decade. So I won't concern myself about finding a mapping for every key on the original keyboards. Some keyboards have duplicate keys, and the Commodore 128, PET Business, and CBM2 keyboards all have a numeric keypad. But I didn't feel it necessary to find a place to map that onto a keyboard that had none. I thought of starting with the keyboard I remembered best, and most wanted to emulate, which was the Commodore 128. But I felt like the Commodore 64 was a better baseline. My plan is to draw up a mapping onto my MacBook keyboard, something that I feel will work for me and meet my goals. At this stage, I didn't know or care how easy it might be to achieve that mapping, or even if it was possible. Let's look at the Commodore 64's keyboard. It can be broken down into 6 groups. The core keyboard, consisting of the letter keys and the spacebar, the number keys, which includes both numbers and the shifted symbols above, the symbol keys, symbols like colon, comma, period, brackets, etc. that are standard, and oddball symbols like the left arrow and the British pound sign unique to Commodore keyboards, the action keys, like the classic run stop and insert delete keys of the 64, as well as other more common keys, the function keys, which on the 64 are both in unshifted and shifted forms, and the transforming keys, Shift, Control, and the classic Commodore key that provide access to alternate characters and key actions. These are pretty much listed in terms of the difficulty of mapping them. The overlap between these groups on each keyboard isn't perfect, but it's a reasonable match. The core keys are an exact match. The number keys mostly match up, though some of the shifted symbols aren't the same. The symbol keys will need some remapping to make things fit and account for unique Commodore keys like the up and left arrows. Some of the action keys match up, and a few additional Commodore keys can get mapped into the additional 4 function keys on the Mac keyboard. The function keys should match fine, though the Mac can use 1 key per function versus the Commodore 64's 2 functions per key. That leaves the transforming keys, where things also match up reasonably well. So I think that's a good plan. Let's dive in and work out the details. But first, there is one keyboard detail left to discuss. A unique feature of Commodore computers and their keyboards was access to a graphic character set known as PETSCII. PETSCII graphic characters were useful in creating simple, and sometimes not so simple, graphics on a text screen grid. Over the years and through various keyboard designs, accessing these extended characters was achieved by different means. On the Commodore 64, most keys had 2 graphic characters shown in the front, not top, of the key. The character on the left was obtained by holding the Commodore key down and pressing that key. The one on the right was obtained by pressing the Shift key along with that key. For most keys, this can be mapped directly, like the Q key. A Shift Q on the Commodore results in a solid circle, so Shift Q on the Mac should do the same. Likewise, a Commodore Q results in a T-junction rotated 90 degrees counterclockwise, so whatever I end up mapping to the Commodore key on the Mac keyboard should combine with Q to get that. But for some keys, this isn't going to be so simple. We saw earlier that the Commodore 64 has a dedicated key for plus, but the Mac doesn't. On the Mac, to get plus, you press Shift and equal. But since the 64 has a dedicated key, it has two graphic characters associated with it. A checkerboard obtained with Commodore Plus, and a heavy cross obtained with Shift Plus. At least one of these will need to be relocated. Here was my plan for my mapping. The core keyboard will map 1-to-1 onto the MacBook. The number keys themselves map 1-to-1, but the shifted number keys not so much. The shifted symbols for 1, the exclamation point, 3, the hash or number sign, 4, and 5 match up exactly. The shifted symbols for 6, ampersand, and the parentheses for 8 and 9 map to the number key after that on the Mac, 7, 9, and 0. Finally, we have cases like how Shift 2 on the Mac is the @ sign, which is a separate key on the Commodore. Same for Shift 8 and the asterisk key. And the caret from Shift 6 gets mapped to the 64's up arrow key. The symbol keys, at least those not already mapped to number keys, would be shuffled around to match the MacBook keyboard. We can start with the easy ones. Both keyboards are identical for the comma, period, and slash keys. Other common symbols map to keys or shifted versions of keys on the Commodore, like minus, equals, plus, semicolon, colon, and the left and right brackets. The single and double quotes fill in the shifted number keys, 7 and 2 respectively, that we didn't map before. The Commodore doesn't have keys for backslash, underscore, and the vertical bar, but it does have pesky graphic characters that look like them, so we can map those. Underscore maps to the Commodore @ key combination, backslash maps to Shift M, vertical bar maps to Shift minus. There are a few other keys and symbols on the Commodore keyboard that we didn't map. We'll come back to them in a bit. The function keys map very simply. The Mac has 12 function keys, the Commodore 64 has 8. So it's an easy mapping of those C64 keys to the first 8 function keys, leaving 4 available for other purposes. The action keys were a bit of a challenge to map out. I chose the following. Return is a 1-to-1 match, so is delete, though unlike the Mac, Shift-Delete means insert on the Commodore. The vastly superior cursor keys of the Mac map to the terrible ones on the 64, so going up means a single key instead of Shift cursor down, same as for left and Shift cursor right. There are 3 action keys on the Commodore that have no equivalent on the Mac. Luckily, we also have some spare function keys there to fill in. Let's map the restore key to F9, and as the home key is way up on the top right of the Commodore keyboard, let's map that to a similar location in F12. Since we've got a key available, we can map clear, that's Shift home, to F11, giving it its own key. That leaves the run stop key, which is really the stop key, but I believe every Commodore user called it run stop. Though some of the keyboards we looked at have an escape key, it really feels better to map the Mac's escape key to stop. This is a case of mapping the intent of the key. An escape stops things on a modern computer, just as stop did on the 64. Of course, that means Shift escape maps to the run part of that key. The transforming keys are mapped out as the Shift keys map 1-to-1. The Commodore 64 did not have a caps lock, but it does have a shift lock, and that seems like a good match. It makes sense to map the Commodore control, or Control key to the Mac control key. That leaves the Commodore key, which seems like a reasonable match to the option keys. But now, getting back to Petsky and the tricky mappings, in order to provide a place for all of the graphic characters available on the C64 keyboard, some had to be shuffled around. This requires using the mapping of the Commodore key onto the Mac's option key to make these work. Let's start with the reverse L shape obtained on the Commodore with Shift @ As this completes a set of 4 such border patterns, the other 3 come from Shift O, P, and L, on the 64, the Shift @ put the final pattern in the sequence in the wrong place, and I can fix that now. I can't map Shift semicolon, since that's the colon symbol, but I can map Option semicolon, and that's what I'm going to do. On the Commodore 64, you can get a big heavy plus symbol by pressing Shift plus. Since plus is Shift equal on the Mac, we can't do that, but we can at least use Option equal to put that graphic symbol on the same key. And if we're going to have a heavy graphic plus sign on the plus, why not map the heavy graphic minus sign obtained by Shift asterisk to the Mac's Option minus combination, especially since the Shift minus Petsky character is the vertical bar we've already mapped. That leaves 5 Petsky graphic symbols that just happen to be easily grouped in 2 types. First, a set of 2 diagonal half patterns. We can map the Shift British pound and Commodore asterisk sequences to the same key. The right bracket key has room for both, and we can at least keep the Shift and Commodore, or Option, part consistent. So shift right bracket, or right brace, maps to shift British pound, and option right bracket to Commodore asterisk. Then we can cluster the 3 checkerboard patterns on the left bracket key and the apostrophe key. We'll stick the half checkerboards on the left bracket key. The vertical half checkerboard of Commodore minus can map to the shift left bracket, or left brace. The horizontal half checkerboard of Commodore British pound can map to the option left bracket. That leaves the full checkerboard from Commodore plus to map to option apostrophe. There's one last symbol to map. Shift up arrow is used to get pi. We can map that to option backslash. Let's talk about a few missing keys. A few keys and symbols remain to be mapped. On the Commodore 64, we have the left arrow key on the top left corner. We can match location and map that to the backtick key on the Mac. While we're mapping that key, we can use shift backtick, or tilde, to map to the other unique key on the Commodore, the British pound sign. Finally, on the Mac, we have a tab key. The default vice symbolic mapping for this key is the Commodore key on the 64. And this makes some sense since there is no tab key on a Commodore 64. But there is a tab key on the Commodore 128's keyboard, a PET business keyboard, and on the keyboard of a CBM2 B128. And my muscle memory is going to have me hitting the tab key and expecting it to move the cursor. So I thought having tab match to space, and shift tab, which means back 1 tab, move the cursor back 1 space, in other words cursor right, would be a reasonable representation. So here's my proposed mapping of the Commodore 64. Next episode, it's time to figure out that vice mapping file. Thanks for watching. I realize this didn't get into the details of mapping keys in vice. I first wanted to set the stage and describe the plan and process I made to create a new, and I hope better, mapping for using a preferred keyboard, in my case the MacBook, to use vice as a true emulator and not just a retro gaming machine. Would you do anything differently? I hope you join me next time as we dive into the VKM file itself.